As teams have been adopting AI coding agents, we've seen a lot of pieces of the workflow just get really strained. I'm sure all of you have felt the review burden, just so many lines of code are getting changed. A lot of teams I'm hearing just feel like they're playing whack-a-mole because things are changing so fast that problems are slipping through the cracks. So we've been working with teams to kind of version control things that are one layer of abstraction above the code. So think your architecture, your rules, business logic, things like that. We know that all of these things are what you and your team have in your brain as context when you're working on these things, but the agent doesn't start with that. So we know that when they are provided those things as context, they do better. But we've also been prototyping, okay, how can we not only provide it as context, but also have enforcement of those rules and enforcement of the architecture? So I've got a demo here to show you. We've been using this internally. A couple of our teams have been using it, the teams that we're working with. And it really does seem to close the loop, and we're getting really good results. We have good observability of how the system is changing. So I just wanted to share. The first thing I'll do is just show you where I'm at in this terminal. So this is inside a forked version of an open source repository called Excalidraw, which I will link in the description. We also have this loaded into Yalla, so I'll link the Yalla public project. So you can actually, because this is open source, all of the documentation, context, architecture, rules, constraints, everything for this project are public on Yalla. So I'll link to that as well. So I'm just in that directory on my machine here. And the first thing that we are going to do is install the Yalla CLI. So the reason we have a CLI is it brings the Yalla tooling to the machine where the agent is working locally. So they have everything that they need to fetch context and then to say like, yes, I promise that I met the rules, I adhere to the architecture that was defined, all of that fun stuff. Okay, once it is installed, what we will do is Yalla init. Okay, so it asks you to opt into stats. If you don't have to, I'm going to say yes. Next, paste in your API key. So it's just checking to be sure that the API key is valid and that it has access to certain projects. So when you go create an API key in Yalla, you can say what projects it has access to. Okay, it detected the projects. So that's good. So it's asking if we want it to install pre-commit hooks. If you haven't used pre-commit hooks before, they are one of the most impactful tools that you can use in your kind of collaborative coding agent workflows. They basically provide a set of actions that have to run and pass before code can be committed. So really, really helpful in nudging the agents to do the right thing. So in this case, we definitely do want the agents to have the pre-commit hook for the architecture, the rules, all of those things that we're working on. Okay, and then I'm going to do the demo with Claude Code. And then it's just asking if we want to set up the MCP server. So in this case, that's how the agent is actually going to go fetch the rules, the latest architecture information, all of that. So I'm going to say yes to that too. Okay, cool. So we're set up. Okay, let's come into Claude now. That should be fine. Okay, so what we're going to do is have Claude implement a new feature, which I will speed through. We don't have to watch it do all the implementation, but then we will watch what it does when it has to commit. So we installed the pre-commit hook where it has to promise, yes, I met the rules, I adhered to the architecture, all of that. If it does have changes to any of those high level, these like new primitives, it just has to report them. That's all. And then we can kind of keep track of them as they go. So I'll speed through this and then we'll take a look when it's done. Claude finished the fireworks feature that I asked it to implement, um, I asked it just to do a quick review of what's there, which is why I included this observation section. Normally, you would go through and review this. I would too, but just for the sake of the demo, I want to show you what happens when we ask Claude to commit its code. So we can see that it is checking what branch we're on. Probably ordinarily you would be on a different branch, not master, when you're making changes. It's looking at the Git history. Okay, and now it's going to add all of the files that it touched. So we'll give it permission to do that. And now it's going to try its commit. So it's got its message in there. I'm not going to read through that. But the commit fails because it doesn't have an attestation. So now it uses the Gjalla MCP to get the latest rules for this project, get the latest architecture spec. There are a few other MCP tools that you'll sometimes see it use just to get the context. Okay. So it's got the context it needs. And now it's going to write an attestation file. So this is a self-attestation, right? It's the honor system, the agent saying, yes, I'm compliant with these rules that I checked, and I did not make any changes to architecture elements. I did not make any changes to the connections. I didn't make any new architecture decisions. This does report a new data flow. So it says data flows changed true, new fireworks WebSocket subtype broadcast between collaborators. That makes sense. And then it also added a capability and gives us a quick summary. So we'll let it write that file. It's actually tied to the Git commit. So all of the architecture and system level changes are directly attributable to each line of code that goes into the commit. Okay, and then it just wanted to check to make sure that it got the hash right. Since they are tied together, it'll try the commit again. And this time it went through. And it says now that we are one commit ahead of master. So this, like I said, is kind of on the honor system for these agents to say, you know, I'm compliant with all of these rules, I meet the architecture, or here's, you know, something that has changed at the system level. But it's a really good step forward, and you can kind of track the history as all of these things are changing. You can have external verification go through and say, yes, we checked all of these self-attestations by the agents, but this really stops the agents from drifting and makes sure that by the time that your team gets to reviewing all of the code that the agents have written, they're not like, I don't know, swimming through all of these irrelevant, potentially wrong changes, right? Like the things that end up needing the review are going to get surfaced because the agents have already, you know, weeded out some of those simple things that, like, that's just not worth your team's time to be fixing those things over and over. So I just wanted to show you how we're kind of closing the loop there on these system level changes and making sure that the agents are actually adhering to them and reporting the changes that are important. If any of this is interesting to you, as always, we're collaborating with some really just awesome teams that are working on some cool tech. We would love to hear from you if you are interested in collaborating as well. If there are any other open source repositories that you want me to load into Gjalla, we'll make all of the documentation public on our website, of course, for open source repositories, and then I'll record a video too going through it. So let me know what you want to see next, and thanks for watching.